All right, sorry for the interruption. Sometimes the computer doesn't work and I end up spending an entire hour recording when it doesn't record anything, so didn't want that to happen. So sorry we have to have two parts to this video, but it'll be fine. Okay, so going back, so we can take out a 5, and when we do that, we end up with x squared minus 9x plus 18. So what two numbers multiply gets you 18, adds gets you negative 9. So hopefully we can see that that would be negative 6 and negative 3. All right, so what is on top that's also on bottom that we can cancel? We can see that x plus 6 is on the top and the bottom, and we can see x minus 3 is on the top and the bottom. So our simplified answer is going to be 5 times x minus 6 times x plus 5 over x plus 3 times x plus 1. All right, so vertical asymptotes. Remember, it's what makes the simplified denominator equal to 0. So from here, we can see that we're going to get x equals negative 3. From here, we're going to get x equals negative 1. Now remember, it's not negative 3 and negative 1, it's x equals negative 3. It's a line. We have to make sure to remember that. All right, so we got vertical asymptotes. Done. Now let's talk about the wholes. So what were the 2 points, the 2 expressions that we deleted, that we simplified? So we can see that we simplified x minus 3. So the 0, or the x-intercept for this that would make this equal to 0, is 3. So 3 is the x value of the whole, of one whole at least. The other one that we canceled was x plus 6. So what makes that 0 is going to be negative 6. So this will also be an x value to a whole. So to figure out what the y value to the whole is, we just plug these values into our simplified equation. So we can see that, let's give us some space. So f of 3 is going to be 5 times 3 minus 6 times 3 plus 5 over 3 plus 3 times 3 plus 1. So we get 5 times negative 3 times 8 over 6 times 4. We can see that 8 divided by 4 is 2, and then 3 and 2 is just 6, so we end up with negative 5. So our point is 3, negative 5. So we have a whole at 3, negative 5. So now let's see what the y value is when we plug in the negative 6. So f of negative 6 is 5 times negative 6 minus 6, negative 6 plus 5, negative 6 plus 3, and then negative 6 plus 1. So we get 5 times negative 12 times negative 1 over negative 3 times negative 5. Well, we can see all the negatives cancel each other out. 5 cancels with 5, and then 12 divided by 3 is just 4. So the next whole is going to be at negative 6, comma 4. And there we go. All right, next, example number 3. So to find the vertical asymptotes and the wholes, first we want to simplify everything. So x squared minus 4, that's a difference of squares, so that's just going to be x minus 2 and x plus 2. X squared minus 8x, notice we can take an x out. So if we factor out an x, we're left with x minus 8. With the bottom, what two numbers multiply gets you 4, adds gets you negative 5. Hopefully we see that's x minus 4 and x minus 1. And then for the last one, we see that we can take out an x, and we're left with x plus 4. So what's simplified on the top that's also on the bottom? Hopefully we see that we can simplify those x's. So f of x, simplified version, is all of this. Good. So vertical asymptotes, we know we're going to have vertical asymptotes at whatever is left over in the denominator. So x equals 4, x equals 1, and x equals -4, right? 4 makes that 0, 1 makes that 0, -4 makes that 0. So we got our vertical asymptotes. We also will have a hole, right? Since we simplified something out, we're going to have a hole. And what makes x 0? It would just be 0, right? So 0 is the y value, and we got to plug it in to figure out what the x value is. Sorry, other way around. 0 is the x value. We need to plug it in to figure out what the y value is. Oh. All right. So when we plug in 0, we just see that that's just going to be all the numbers that we got, right? So -2 times 2 times -8 over -4 times -1 times 4. So we can see 2 and -2 just cancels out with the -4. And then -8 divided by -4 is +2. So our hole is going to be at 0, 2. Last one. All right, so how can we simplify? So the denominator, we can see that's just going to be difference of squares. So x plus 2, x minus 2. Now, how can we simplify the top? So we might need to review just real quick. Some people either might not have been taught or just forgot. But we got to talk about the difference and sum of cubes. So if you have something cubed minus something cubed, that's going to be, so if it's a cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. If you have a cubed plus b cubed, excuse me, that's going to be a plus b times a squared minus ab plus b squared. So one easy way to remember this, because if you notice, all of the letters are the exact same, right? No matter if it's adding or subtracting here, it's always a, b, a squared, ab, b squared. So the question is, what's an easy way to remember which sign is which? Well, we talk about, the way to remember that is SOAP. So SOAP stands for, S is same. So if you start with negative, it's also negative. If you start positive, it's also positive. O is going to be opposite. Right? So this was negative, now it's positive. It's positive, now it's negative. And then AP is always positive. Right? No matter which one we had, we were always adding the b squared. And a cool thing that we find out is that this will always be prime. At least prime amongst the integers. So there's no more factoring after we get it down to here. All right, so going with this one, going back to this problem, we see that this is going to be x cubed minus 2 cubed. So using our equation, this is minus, so it's same. So also minus x squared opposite plus 2 times x, and then always positive. So plus 2 squared. So we can see that we get x minus 2 times x squared plus 2x plus 4. And we don't have to check this. This doesn't simplify anymore. So notice that we can cancel out x minus 2 on the top and the bottom. So our simplified equation is x squared plus 2x plus 4 over x plus 2. So vertical asymptote is going to be where x can still turn that into 0. And so we see that that's just going to be -2. X equals -2. Good, yeah, it's not just -2, right? -2 is a number. It's x equals -2. It's that line. We're going to have a hole. Right? Since we simplified something, we're going to end up with a hole. So the hole is going to be at 2, right? The x value is going to be 2. So to find the y value, we just plug it in. So f of 2 is 2 squared plus 2 times 2 plus 4 over 2 times 2. And we can see that's 4, and that's 4. So this is just 12. This is also 4, so 12 divided by 4 is 3. So our point is going to be at 2, 3. And by point, I mean the hole. Our missing point is going to be at 2, 3. All right, let's move on to not harder, but different. Unfortunately, there's more rules that are just unfamiliar to us that we have to remember. All right, so we talked about vertical. Now we got to talk about the horizontal and oblique. So horizontal asymptote, right? That's going to be this asymptote. And of course, horizontal lines always have y equals. So if we let it be y equals c, then what we know is that our function, the y value, is going to be approaching c. It's getting closer and closer to c, as x approaches infinity or negative infinity. So basically something like this, it could look like if you have x going further and further towards infinity, it's going to get closer and closer to this horizontal asymptote. Right? And that can be from above as well. Likewise, it can also go negative. Right? Go to negative infinity, get closer and closer. The y values get closer and closer to c. Another one, and we will talk about this. So it could actually cross the horizontal asymptote at some point. So it could go something like this. It crosses, and then it gets closer and closer to c. So that's also a possibility. And like I said, we'll see some examples like that. An oblique asymptote is a line. So basically, it's going to be a line that's not vertical or horizontal. So it's just going to be y equals ax plus b, where it approaches this line as x approaches infinity or negative infinity. So if it looks something like this, right, as x gets bigger, the y value is going to get closer and closer to this line. Or if it's negative, right, it gets closer and closer to the line. All right. So here's how we figure it out. When do we have a horizontal asymptote? When do we have an oblique asymptote? So for our class, we will never have both. You either have a horizontal asymptote or you have an oblique asymptote. Okay, so let's talk about the initial form. So don't let this trip you up, right? This is just the standard definition of a polynomial, right? On the top and the bottom. So basically, this is, right, you see n minus 1. This just means it's getting smaller. So this is going to be something like 3x squared plus 4x minus 3, right? Over 7x cubed plus 3x squared minus 5x minus 7 again, right? That's all this means. So basically, remember, n is going to be the biggest degree, or sorry, the biggest exponent, which is known as the degree, and k is also going to be the biggest one, right? Because it's k minus 1, so it gets smaller. So k is the biggest exponent, n is the biggest exponent. So if the exponent on the top is less than the bottom, if the degree of the top is less than the degree of the bottom, we have an asymptote, horizontal asymptote at y equals 0. And since we have a horizontal asymptote, we don't have an oblique asymptote. The second one, if n equals k, so if the degree of the top is the same as the bottom, you're going to have an asymptote at y equals, so you see this x to the n, it's going to be the leading coefficient. So it's going to be the a in front and the b in front. So basically it's just the leading coefficients. And I can actually show you how, if you want, you can just kind of combine those two rules into one rule. We can just combine it into that rule if you want less things to remember. And then lastly, if we got it less than, equal to, the last one's greater than. So if it's greater than that, there is no horizontal asymptote. Because essentially you can actually divide it out. So instead, there will be an oblique asymptote, and the oblique asymptote is the quotient when you actually divide it out. So unfortunately, we're going to have to do some polynomial division. If you don't remember that, we will go through a couple of different problems to hopefully remind us. All right, so same example, right? Example number 1. Let's find the oblique and the horizontal asymptotes. So we can see that the degree of the top is 0, right? Because where are the x's? There's no x. So essentially it's just x to the 0. What about the bottom? We can see that the degree is 1. So since 0, the top is less than the bottom, we have y equals 0 is the horizontal asymptote, which means that we have no oblique asymptote. That was it. Okay, let's look at example number 2. So one thing that we could do is we could multiply these out, right? We could, because right now, this isn't the form that it wants, right? It wants it in the standard form, where it's all adding. There's no multiplication anymore, right? So one way to do that is we could just multiply these numbers out, right? X squared times 7x. We can just distribute all this out. That's a lot of work, and we don't really need to do that, right? So instead, what we could do, if you notice, in this polynomial, right, what is the highest exponent? It's this 5x squared. In this polynomial, what's the highest exponent? It's x squared. So then the highest exponent ever on the top is going to be when you multiply these two together, right? That's the only way that you're going to get the highest exponent. Everything else is going to be less, right? 5x squared times 11x, that's a 3. 5x squared times no x, that's just 2, right? X squared. So when you multiply these two together, you're going to get 5x to the 4th. Same thing with the bottom, right? The highest exponent on the first polynomial is x squared. The highest exponent on the second one is x squared. So when you multiply these two together, you're going to get x to the 4th. So which means the degree of the top is going to be 4. And the degree of the bottom is going to be 4. So since they're the same, right, we know that we are going to have a horizontal asymptote at y equals, and it's the coefficients. So the leading coefficient is, this is the leading term, so the coefficient in front is 5 over, the coefficient in front is 1. So 5 over 1, which is 5. So there is a horizontal asymptote at y equals 5. Since there's a horizontal asymptote, there is no oblique asymptotes. Oop. There we go. All right, we can do the same thing with this one, right? We can see the highest exponent is going to be x squared and x squared. So this is x to the 4th. X squared. So once again, x to the 4th. So the degrees of these are the same at 4. So that means that we are going to have a horizontal asymptote at the coefficients, right? So 1 is the coefficient of the top, 1 is the coefficient of the bottom. So when we divide that, we get 1. So there is a horizontal asymptote at y equals 1, which means that there is no oblique asymptote. All right. So you may have remembered that I said that you can actually combine those first two rules into one, and here is how you can do it. So if you remember this rule that we kept saying, right? Make it, when they're equal, it's the top, the coefficient of the top divided by the coefficient of the bottom, the leading coefficient. So if you have this 1 over x minus 4, notice that this is the same as if we added 0x plus 1, right? Because 0 times x is just 0. So now the degree of the top is 1, and the degree of the bottom is 1, right? So since they're equal, we know that we're going to have a horizontal asymptote at y equals the coefficient of the top over the coefficient of the bottom, which is just 0, which is where they get that. So If you want to just do it this way, you absolutely can. However, if you want to just know the 3 rules, that's fine too. Let's look at number 4. All right, so let's find the horizontal or oblique asymptotes. So we can see the degree of the top is going to be 3. The degree of the bottom is 2. So since the top is bigger than the bottom, we don't have a horizontal asymptote. Instead, we have an oblique asymptote. So to find the oblique asymptote, you actually have to divide them out. So x cubed minus 8. And let's give the places for the x squared and the x's, right? So 0x squared, 0x minus 8. So remember, we look at the highest powers for both of these. So what times x squared is x cubed? X. So then, just like regular division, we multiply. And we multiply this to everything. So x times x squared is x cubed. X times negative 4 is negative 4x. And we can place it underneath the columns that are correct. Then we subtract. This is the thing that everyone forgets about. Because when you subtract, you have to flip the signs of everything. So the x cubes cancel, and we're left with 4x minus 8. Now notice, nothing times x squared gives you 4x, right? Well, it would be x over, or 4 over x, which is not part of a polynomial, right? Polynomials have to have positive exponents with their x's. Good, so we're done. And this is the quotient. So we have an oblique asymptote at y equals x, what our quotient was. And that's it. All right, so let's do a couple more examples, maybe like 2 more examples, just to make sure that we do understand the oblique asymptotes. So we're not going to graph these, so you can just have these off on their own. All right, so we can see that the degree of the top is 2, the degree of the bottom is 1. Since 2 is bigger than 1, we know we're going to have, we don't have any oblique, we don't have any horizontal asymptote, so we do have an oblique asymptote. So let's actually divide it out. So we get x squared, let's give a place for the x, and then minus 9, divide by 2x minus 4. So what times 2x is x squared? Well, let's look at just the x's. So what times x is x squared? X. What times 2 is 1? Because there's an invisible 1 right there. 1/2, right? Half of 2 is 1. So then we multiply. So 1/2 x times 2x is x squared. And we multiply by everything. 1/2 x times negative 4 is negative 2x. And then we subtract. And when we subtract, we flip the signs of everything. X squares cancel. So when we add these together, we get 2x, bring down minus 9. So what times 2x is 2x? Obviously, that's positive 1. And notice, if you didn't remember to change the sign, you would have had negative 2x and you would have gotten the wrong answer. So positive 1, then we multiply. 2x times 1 is 2x. 2x times negative 4 is negative 4. We flip the signs and then add. So we end up with negative 5. And we're done, right? Because you can't multiply the x by anything to get 5. So this is our oblique asymptote, right? We'll have an oblique asymptote at y equals 1/2 x plus 1. Part B. So for part B, notice the top, we have the degree of 2. Bottom, we have degree of 1. 2 is bigger than 1, so no horizontal asymptote. If you want to go ahead and you can try to do this on your own, pause the video, see if you get the same thing I do. That might be helpful too. So we're going to divide out. And notice, some of y'all might be thinking, well, how come we're not doing synthetic division on all these? Because synthetic division only works when you're dividing by an x plus c. So last time we had a number in front of the x, so that doesn't work. For the one before that, it was an x squared. So we couldn't use synthetic division for any of these. And if you try, it's not going to work out. So technically, this is the only one we could use synthetic division for. But since we're not talking about synthetic division, we're only going to be talking about regular division. So let's just practice with that regular division. So what times x is x squared? We see it's x. X times x is x squared. X times 2 is 2x. Then we subtract. So flip all the signs. X squares canceled. Then we get negative 6x. Bring down the plus 1. So what times x is negative 6x? We get negative 6. Negative 6 times x is negative 6x. Negative 6 times 12 is negative 12. Then we flip the signs. 6x's cancel, and we're left with 13. So we're going to have an oblique asymptote at y equals x minus 6. All right, and that was it. So that was all the hard part. So now let's actually do the strategy of putting it all together. So first step you want to do, you want to simplify, because we're all going to want to simplify first anyway. So the first thing we should do is figure out what are the vertical asymptotes and the holes. So step 1, find all the vertical asymptotes, find all the holes. Step 2, find the x-intercepts. Step 3, find the y-intercept. There's only one if it's a function, right? Step 4, then find all the horizontal and oblique asymptotes. So you might notice there is a pattern to the first 4 steps. So basically we talk about the vertical asymptotes. We're all going to have x equals stuff. Then we go into the x-intercepts. Then we flip it up, and instead of the x-intercepts, we talk about the y-intercepts, so the other intercepts. And then we talk about the y-asymptotes, right? Which are going to be the horizontal and the oblique. Those are all the y equals asymptotes. So that's kind of how I think about it. I mean, it super doesn't matter what order you do it in. At least these first 4. It doesn't matter what order you do them in. But there's a rhythm to this, so might be helpful. Also, remember, if we do have a horizontal asymptote at y equals c, remember we did say that the graph might cross at that point at some point, right? So we have to check, is there ever a point where it crosses that that horizontal asymptote? So basically we need to find what x-coordinate makes f of x equal to c. And then we have another point. And the more points we have, the easier figuring out what this graph is going to look like. So last thing is we just sketch it. And then we determine how the graph approaches each vertical asymptote. So another thing, you need to make sure that when you do your pen, right, when you go from left to right, you include everything, right? The only values that x can't be are any vertical asymptotes and holes. So if you have a vertical asymptote here, and here, and here, and you only graph this much, right? Well, what about all the stuff over here? What about all the stuff over here, right? How does it approach, how does the graph approach this vertical asymptote from the left? Does it go down? Does it go up? We got to figure that out. So just because it looks like you've figured everything out, make sure just kind of go real quick, go left to right. Oh, we don't have anything over here. So what's going to happen to the graph? Oh, we don't have anything over here. What happens to the graph? All right. So example number 1. So first thing, vertical asymptotes and holes. So we already said we had a vertical asymptote at x equals 4, and we don't have any holes. Number 2, x-intercepts. So x-intercept is when y equals 0. So 0 is 1 over x minus 4. Fractions suck, get rid of them. So we can multiply by x minus 4, and we get 0 equals 1, which doesn't make any sense. So that means that there are no x-intercepts. All right, third one, y-intercepts. This is when x equals 0. So y is 1 over 0 minus 4, which is negative 1/4. So we have the point 0, negative 1/4 on our graph. So maybe it'll be easier to find it later when we need it. Yeah, like I said, more points. The more points we have, the better things are going to be for us. Number 4, horizontal asymptotes and oblique asymptotes. So remember we said we had a horizontal asymptote, for example, number 1, at y equals 0. And we don't have any oblique asymptotes. So step 5, since we do have a horizontal asymptote, we have to check, is there ever a place where our graph crosses that horizontal asymptote? So basically we make the whole thing equal to 0. And this should look familiar because we've already done this, right? If you multiply by x minus 4, you get 0 equals 1. So never. So does it cross there? No, it doesn't. All right, and then part 6 is to sketch it. Okay, so we said that we had a vertical asymptote at x equals 4. And we had a horizontal asymptote at y equals 0. We also know that we have a y-intercept point at 0, negative 1/4. All right, so let's just start with, that's all we got, right? We don't have any other points. Those are the only 3 things we had. So let's start with this point. So as it goes to the left, right, notice maybe it goes down to a negative infinity, right? But more than likely, since there is a horizontal asymptote, what's going to happen is it's going to get closer and closer to this horizontal asymptote, right? So it's just going to get closer and closer to 0 without ever touching it. Now, let's look at it when it goes to the right. Well, obviously, this is a vertical asymptote, so it can't just go straight through it, right? It can't touch it. It could go up, but that doesn't make any sense, right? We know that it doesn't ever cross the x-axis. It doesn't cross this horizontal asymptote. So the only place for it to go is straight down, right? It just hugs that vertical asymptote. All right. Notice we are not done. Because if you go from left to right, we have this values, but then what about this side? We don't have any values over here. So what we're going to have to do is we're going to have to do a checkpoint. So what would be a value on this side of the vertical asymptote? So notice if this is 4, we're not going to want to plug in 2 into our equation because 2 is right here, right? We know it's going to be below 0. We need to check something on this side. So 5, right? 5 would be a perfectly good number to check. So if we plug in 5, we see we get 1. So we know now that another point on this graph is 5, 1. So if we graph 5, 1, all right. Well, as it goes to the left, notice again, it can't go down, right? Because it can't cross the horizontal axis. So, and it can't go through, right? So it just has to go up to positive infinity. And again, maybe it goes straight up to infinity on the right side, but since there's a horizontal asymptote, what probably happens is it just gets closer and closer to that horizontal asymptote. So this is what our graph is going to look like. All right. So for number 2, remember we already simplified this, so let's not do it all over again. So we simplified this to 5 times x minus 6 times x plus 5 over x plus 3 times x plus 1. So we said that we had vertical asymptotes at x equals -3 and x equals -1. We also said we have holes at 3, -5 and -6, 4. So here's some helpful information for us. Next, x-intercepts. So that's when y is equal to 0. So we're just going to set the whole thing equal to 0. And if you notice, basically what this is going to be is the x-intercepts are going to be when the numerator is 0, right? So vertical asymptotes are when the denominator is 0. X-intercepts are when the numerator is 0. Because when you multiply everything by the denominator, you end up with 0 is 5 times x minus 6 times x plus 5, right? So basically we see that this means x is going to be at 6 and at -5. So the points that we get for our x-intercept is 6, 0 and a -5, 0. Now let's talk about number 3, the y-intercepts. This is when x is 0. So when x is 0, we get 5 times -6 times 5 over 3 times 1. So -6 divided by 3 is -2. So we see that this is just going to be -50. So we have a point 0, -50. All right, number 4. Remember, we already did the horizontal asymptotes for this one, and we said there was a horizontal asymptote at y equals 5, which means that there is no oblique asymptote. So step 5, since we do have a horizontal asymptote, we have to ask ourselves, does the graph ever cross? Do we have any x values that makes f of x equal to 5? So we just gotta plug that in. So 5 equals 5 times x minus 6 times x plus 5 over x plus 3 times x plus 1. So we can multiply by the denominator and get 5 times x plus 3 times x plus 1 equals 5 times x minus 6 times x plus 5. So we can cross out the 5s, right? Because those are both sides, just divide each side by 5. And unfortunately, it looks like we're going to actually have to multiply these out, right? Full them out. So for the left side, we get x squared plus 4x plus 3. For the other side, we get x squared minus x minus 30. We can see we can subtract x squared to both sides, get rid of that. So adding x to one side, we get 5x. Subtracting 3 to the other side, we get -33. So x is -33 over 5, which is -6.6. So we do know that the graph crosses the horizontal, or it does cross the horizontal axis at -6.65. So step 6, let's sketch it. All right, we said that we had horizontal asymptote, or sorry, vertical asymptotes. At x equals -3 and -1. So -1, -3. We also know we have x-intercepts at 6, 0 and -5, 0. We also have a y-intercept at 50. So we'll just put something really far down here. Doesn't have to, it's just a sketch, it doesn't have to be perfect. But we can kind of see where that side of the graph is going to go, right? Not going up to infinity. All right. And then we have our horizontal asymptote at 5, y equals 5. And then we also said we have a point at about negative 6.65. So negative 6.6 would be right here, 5. All right. So looking at this. Oop. So maybe, there we go. So from this graph, or from this side, obviously this side's going to be the easiest side to do, right? This is just going to go up to the horizontal axis, connect with this point, and then just go down to negative infinity. On this side, we can see it also, this is going to come down to negative infinity, go up to this point. Now, here's the thing though, because the question is, does it just touch at this point and then come back down, or does it actually go through? So unfortunately, we're going to need another checkpoint. So we need something past negative 6, right? Negative 6.6. So negative 7. So let's check negative 7. And we can definitely give some more space. Yeah. So at negative 7, we have y equals 7 times negative 7 minus 6 times negative 7 plus 5 over negative 7 plus 3, negative 7 plus 1. So we get negative 13, negative 2, negative 4, negative 6. So this is going to be 2. And so if we do some quick calculations, right, we can just plug into the calculator. We see that we get 7.583 repeating, right? These negatives cancel. So notice, is this above or below our horizontal asymptote? It's above it, so we know that it does go through that point. And again, it could go all the way up, but since we do have a horizontal asymptote, what probably is going to happen is it's going to continue to get as close to that value as possible. So this is almost done. Why is it almost done? Why are we not done yet? Well, we don't know what happens inside here, right? We never did anything there. So we're going to need to do another checkpoint. So let's do another checkpoint. Obviously, negative 2 is going to be between these two. All right? So if we have y equals 7 times negative 2 minus 6, negative 2 plus 5 over negative 2 plus 3, negative 2 plus 1. So we see that, I guess we're going to need some more space. Writing pretty big now. So 7 times negative 8 times negative 3, or positive 3, my bad, over 1 times negative 1. So yeah. Mm-hmm. Yeah. So we end up with, we multiply that out, $168. Did I do that right? Just double checking. Negative 2, negative 8, yep. Okay. Regardless, definitely over 5, right? Oh, it's not a 7. This is a 5. Oh, my bad. That's why I was getting something weird. Oh, no. Okay, so let's just double check again. So I'm sure all of y'all already saw that. So I'm glad we got it. We caught it, though. So this is supposed to be a 5, not a 7. My bad. So when double checking for -7, right, we end up with 5 times 13 divided by 2 divided by 6. Ooh, okay. So we get 5.416 repeating, which is cool. Okay, still above 5. So we still know it goes above it. So we're all good there. Okay. So we multiply this out, we get 120, which is what my notes had said. Good. Okay. Definitely greater than 5. So that means that on this side, when the graph goes, right, wherever -2 is, way up here, doesn't really matter, right? We know it's going to go up and then up. Like that. All right, because it can't go through and it can't go down. So that's about what it's going to look like. All right, and here we go. All right, let's do number 3. So, vertical asymptotes. We said first we should talk about, remind ourselves what the simplified version was. So we said the simplified version was x plus 2, x minus 2, x minus 8, x minus 1, x minus 4, x plus 4. So vertical asymptotes. We already said we had vertical asymptotes at x equals 1, x equals 4, and x equals -4. And then we said we had a hole at 0, 2. So that information will be helpful. Ooh, wait, no, we had holes. Oh, I'm so sorry. Ooh, this is just not going well. Yeah, we had holes here, right? We forgot to talk about the holes. So sorry, I'm so sorry. This is not going well. So for example number 2, we had holes and we forgot to put the holes in, right? So we had a hole at 3, -5. So there should be a hole right here. And then we had another hole at -6, 4. So -6, go up to 4. We had another hole there. Okay. Let me just double check just to make sure we got everything. Got our asymptotes, got our holes, got the y-intercept, the x-intercepts. We got our point going through the horizontal axis, or horizontal asymptote, and the horizontal asymptote. Okay. This is officially it. I am so sorry. Yes, this is it. Okay. So, going back to this one. Number 2. So, for number 2, x-intercepts. So, we let y equal 0, and then solve. Which again, we said that's really just going to be all the top numbers, right? 0 is going to equal x plus 2, x minus 2, x minus 8 when we multiply by the denominator, which means that x is -2, +2, and +8. So we have points at -2, 0, 2, 0, and 8, 0. Number 3, we got to find our y-intercepts. So y-intercepts are when x equals 0. So we get 2 times -2 times -8 over -1 times -4 times +4. So the 2 and -2 cancels out with the -4. Negatives cancel, so we are left with 2. So we have a y-intercept at 0, 2. Wait a minute, that looks familiar. Oh yeah, that's where our hole is, right? So since there's a hole there, we can't have an x-intercept there, or a y-intercept there. So there are no y-intercepts for this problem. Number 4, horizontal asymptotes. Remember we had one at y equals 1, and then we had no oblique asymptotes. So step 5, since we had a y-intercept at y equals 1, we have to ask ourselves, does that ever cross? Number 5, does the x ever cross to 1? So we let 1 equal our equation, so x plus 2, x minus 2, x minus 8, x minus 1, x minus 4, x plus 4. So we multiply by the denominator and we get this. Oh no, it looks like we're going to have to multiply it out. But that's okay, right? So look, here we have x minus 4, x plus 4. So we know that's just going to be x squared minus 16. Right here we also have x plus 2, x minus 2. So that's going to be x squared minus 4. Okay, this isn't nearly as bad. So on the left side, we have x times x, which is x squared. And by that I mean x cubed, of course. We have negative x squared, negative 16x plus 16. On the other side, we have x cubed minus 8x squared minus 4x plus 32. We can cancel out our x cubes. We can move everything to one side. So if we move everything to one side, we have 7x squared minus 12x minus 16 equals 0. So we got to solve. Quadratic formula always works. So let's use the quadratic formula. So x equals negative 12 plus or minus the square root of negative 12 squared minus 4 times 7 times negative 16 divided by 2 times 7. So we see that that's 12 plus or minus the square root of 592 over 14, which means that when you add and plug into your calculator, right, we get about 2.6. When we subtract, we get about negative 0.9. Let me just double check that just to make sure. Yes, okay. So that was the x value. What was the y value? Y value was 1. So we have points at about 2.61 and negative 0.91. Which is good. Like we said, the more points, the better. Okay, so let's draw it all. Okay, so let's just start with number 1. We'll do everything. We won't skip around like I did last time. Okay, so we have vertical asymptotes at x equals 1. At x equals 4, and x equals negative 4. We have a hole at 0, 2. We have x-intercepts at 2, 0, negative 2, 0, and 8, 0. We don't have any y-intercepts because we have that hole. We have a horizontal asymptote at y equals 1. And then we have two more points. We have the point 2.61, so 2.6-ish. It's going to be right here. And negative 0.91. Okay. So, let's just go with the right side, because these are all the points we got. So on the right side, obviously, when it goes to the right, it's going to just get closer and closer to that horizontal axis. When it goes to the left, it's going to go down to negative infinity. Let's look at what's in between these two. So obviously, at this point, at the x-intercept, when it goes to the left, it's going to go down, and then it's going to connect. Now the question is, of course, does it connect and go up, or does it connect and go down? Well, we could do a checkpoint, but another thing we can do is kind of use some common sense. If it goes down, that means that it's going to have to cross the x-intercept, the x-axis again, right? But we said these were the only times it crossed the x-axis, which means that it can't go down, it has to go up. And then if it goes up, it's going to go closer and closer to infinity, right there. Hopefully that makes sense. All right, when we start at this point, this x-intercept, obviously to the left, it's just going to go down. Then it's going to go through that point. Since we have a hole, it actually tells us, hey, it has to go to the hole. So it actually does go up, so we don't have to guess at all. Now, the question is, we still got this part on this side of the horizontal axis, or horizontal or vertical asymptote. So we can either do a checkpoint, right? We can do a checkpoint something less than -4, right? -5, -6, and you can see it from there. Another one we can do is, again, let's assume it's on the bottom. If it's on the bottom, then at some point, if it's going to get as close to this line as possible, it's going to have to cross the x-axis to go down to infinity, or negative infinity, right? But again, since there isn't a point on this side that actually crosses, we know that it's not going to go on the bottom. So it has to be up top. So if it's up top, right, going to the left, it's going to get closer and closer to the horizontal axis, asymptote. Then to the right, it's going to get closer and closer to that vertical asymptote. So this is what our graph will look like when we are done. All right, last one. So we said that we could simplify this down to f of x equals x squared plus 2x plus 4 over x plus 2. So we said that, number one, vertical asymptote was at x equals -2. Hole was at 2, 3. Number two, x-intercepts. So let's let y equal 0. So we got 0 equals x squared plus 2x plus 4 after we multiply by the denominator. So we got x is -2 plus or minus the square root of 2 squared minus 4 times 1 times 4 divided by 2. Times 1. Notice the inside, right? That's just going to be 4 minus 16, which is -12. And since we're taking the square root of that, that's not going to be a real number. So there are no x-intercepts this time. Number 3, y-intercepts. So we let x equal 0. So y is going to be 0 squared plus 2 times 0 plus 4 over 0 plus 2, which is just 4 over 2, which is 2. So we have a point at 0, 2. Remember, number 4, we said we don't have any horizontal asymptotes, but we do have an oblique asymptote at y equals x. Number 5, since we don't have a horizontal asymptote, we don't have to worry about number 5, because there's no asymptote for it to cross anyway. So, number 6, let's actually graph it. We said that we have a vertical asymptote at x equals -2. We said we have a hole at 2, 3. We also said we had a no x-intercepts. We do have a y-intercept at 0, 2. No horizontal asymptotes. We do have an oblique asymptote this time at x equals y, or y equals x, right? So basically, we have an asymptote that looks like this. All right, so if we look on this side, from the hole, as it goes to the right, it's just going to get closer and closer to that asymptote. Then we're going to connect to the left, since there's a vertical asymptote and it can't go down because it can't cross the oblique asymptote, it's just going to go up to infinity. And notice on this side, it actually continues off to infinity. So we are done with this side of the vertical asymptote, the right side. So I got to ask ourselves about the left side of the vertical asymptote. So once again, we can plug in a point. However, notice there were no x-intercepts. So either, right, it's going to look like this, where it goes underneath here, underneath this oblique asymptote, or it's going to go above. If it goes above, and it actually gets closer and closer to infinity and closer to this y equals x, at some point it's going to cross the x-axis. But since it never crosses the x-axis, we can see logically it can't be up here, right? So it actually has to be down here. And it's going to look something like that, right? As it goes to the left, it's going to get closer and closer to y equals x. And then as it goes to the right, it's going to get closer and closer to negative infinity. And here we go. Here's our graph. This is what the graph will look like. All right. Hopefully that was the hardest part, but now we have to do the opposite. So we got 2 more examples, or a couple more examples. 4 more examples. But this part hopefully should be easy. So it's the exact opposite. So if I give you all the stuff, can you give me what the equation is? Trust me, this is way easier than what we've been doing. Because once you already have all the stuff, now it's super easy. So vertical asymptotes. Remember vertical asymptotes. Where are the vertical asymptotes? Where do we find vertical asymptotes? On the bottom, right? So if we have a vertical asymptote at x equals -3, then that would mean that what value, when you plug in -3, makes it 0? It's just x plus 3, right? X plus 3 is going to make -3, 0, right? -3 plus 3 is 0. And then we have x equals 2, so that's just x minus 2, also on the bottom. Easy. The next one, the x-intercepts. Remember we said the vertical asymptotes are on the bottom and the x-intercepts end up being on the top. So if we have -1, that's just x plus 1. If we have 0, that's x minus 0, or just x, right? So if we just want to make it look a little prettier, we can put that up front. We also have a hole at 1. So remember when we had a hole, that means that we crossed out something. All right, so that means it has to go on the top and the bottom because it eventually needs to be simplified. So at 1, if x is 1, then that would be x minus 1 on the top and x minus 1 on the bottom. All right. Now we just need to know what are the coefficients in front. And what we have here is that horizontal asymptote. So 1, if we have a horizontal asymptote and it's not 0, then the top and the bottom degrees need to be the same. And if we notice, we have 1, 2, 3 x's on the top. So this is going to be a degree of 3. 1, 2, 3 x's on the bottom. Well, vice versa. 3 on the bottom, degree of 3 on the top. So they're the same, which means that it's just going to be y equals the coefficient over the coefficient. So that's going to be 1 over 4. Or we can just leave the 1 out. Good. And this is it. We're done. That's the answer. See? Way easier than what we've been doing. Let's do another one. Number 7. Yeah, and remember, if you need to pause this, write everything down before I start, that's totally cool too. If you want to pause this and try to see if you can do it on your own, also cool. All right, so we know we have f of x equals something. So vertical asymptotes go on the bottom. So that's going to be x plus 5, x minus 3. X-intercept goes on the top. So that's x plus 1. Holes go on the top and the bottom. So x minus 2, x minus 2. We know we have a horizontal asymptote at y equals 0, which means that the top has to be less than the bottom. And if you notice, the degree of the top is 2, the degree of the bottom is 3. So that's good too. So we're all good there. The only thing we haven't talked about is when you plug in 0, you should get -2. So don't forget, there is a coefficient out front, right? There is some coefficient a out front. So we just need to be able to solve for a. What is that coefficient? Since it was 0, it can't be 0, right? Because then the whole thing is just f of x equals 0. So that's a trick. Don't let that trick you. If it says y equals 0, you can't just plug 0 out front, right? Because then the whole thing just multiplies out to 0. So we need to actually figure out what is that. Because the 0 just tells us the degree of the top is smaller than the degree of the bottom. So let's plug it in. So we know -2 is the result when you plug in 0. So we get 0 plus 1 times 0 minus 2 over 0 plus 5, 0 minus 3, 0 minus 2. We already know these cancel, right? That's pretty easy. So -2 is going to equal 1 over -15. So when we multiply those two, right? Fractions suck, get rid of them. We see that a is going to be +30. So if we plug it back into the original equation, since it's 30, right? 30 over 1, we see that the 30 is just going to go on top. So this is our equation. Now, if it was 1 over 30, right, it would go on the bottom, but that's not the case. Oh. All right, 2 more examples just like those, just to remind us of what we've been doing already. All right, well, let's not worry about that. There we go. All right, all done. I don't know what's happening. Stop it. Okay. So, we're trying to find a rational equation, rational function. So, vertical asymptote, we see x plus 5, x minus 5. Actually, that should be the other way around, but it super doesn't matter, right? X-intercepts go on top, so that's x minus 2, x plus 1. And then we have a y-intercept at, which would be 0, 4. So we can plug in our point to figure out what is a, right? So 4 is a times negative 2 times 1 over negative 5 times 5. And I'm just plugging in 0, right? 0 minus 2 is negative 2, 0 plus 1 is 1, 0 minus 5 is negative 5, 0 plus 5 is 5. So 4 equals a times 2 over 25. So if we multiply by 25 over 2 to both sides, those cancel to get 2. So we see that a is 50. So we plug it back into our equation. Since 50 is 50 over 1, right? We can just plug it in on the top. That's it. We're done with that problem. Last one. All right, f of x equals, so vertical asymptote. We know we got x plus 2 on the bottom. X-intercept, we got x minus 4 on the top. A hole, that means on the top and bottom we have x minus 1. And then we have a horizontal asymptote that's not 0. So let's just double check. The degree of the top is 2. The degree of the bottom is 2. All right, we're all good. So then we just write negative 3 over 5. And that's our answer. Now we're done. All right, hopefully between all of this is making sense. Like I said, this is probably something very different than you've ever seen before. So if you have any questions, definitely let me know. If I accidentally confused you on some of those problems, definitely let me know about that too. Other than that, you have a great day.